Welcome to the introduction of the RIEGL VMX-250 to the FIG conference here in Sydney, April 2010. It's a twin laser system with an inertial measurement unit and a GPS, which allows us to do kinematic scanning. Here's the system being mounted onto a standard vehicle using two-lay roof bars. It's a very simple operation. It takes about 30 seconds. See, these just removing the laser covers here with a very simple 3-point mounting system. Single cable to connect all of the items. And here's the system on top of the roof. We're now doing initialization of the inertial measurement system by running figure of eights around an open car park here. It's very important that this system is initialized in order to get the accuracy. And here's a result of two normal road speed runs across the Anzac Bridge. We've been driving in the slow lane at the road speed of 60 kilometers per hour with normal vehicle traffic. And around midday, you can see on the road surface there we've got some vehicle noise. This can be cleaned out in a post-processing software. Here we're now approaching the Sydney Harbour Bridge. Again, we're travelling in about the second lane here on the bridge. This data is the result of two passes, one in the north direction, one in the south direction. You can see nicely here we've picked up all of the steel structures, including all of the overhead items. Again, we've got car noise in here, but this can be cleaned out at a later stage. This is a very nice fly-through of North Sydney, where we've got some tall buildings up to 30 to 40 stories tall. Very good look at the maximum range of the VMX-250 lasers, up to 500 meters. This is unique in mobile mapping systems. It's important to remember this has all been shot in just two passes along the main highway down there. What we've done is we're now going to move the system very quickly and simply straight from the vehicle and put it onto a boat, because we're going to scan the same area from the shore, from the boat. This took about 1 hour to take the system off the vehicle and incorporate it onto this boat. We then initialized the system by being in a static location for 5 minutes to initialize the GPS. We then launched the boat. And immediately after launching the boat, we initialized the IMU, again by running figure of eights, similar to the shore-based system where we ran figure of eights around the car park. Here we ran figure of eights around on the open ocean. These are the specifications of the system. What we're going to do now is have a look at the results of this ship-based data. So here we are coming in to the iconic Sydney Opera House. All of this data was shot from the vessel you saw, running around 20 to 30 meters from the shoreline, with the system running at about 300 kilohertz. We maintained all normal Sydney Harbour maritime rules, so this was done without any special permission or regulation. All of the data you're seeing here now is a result of the shipborne lasers. This is a very interesting shot as we come in under one of the finger piers here, which are very old Victorian piers. You can see the penetration underneath the piers. generally ran at about 6 knots. Here we have a fly through it coming down on top of the botanical gardens. See the Sydney Opera House and the bridge in the distance there. And what we want to do and demonstrate with this particular pass of data is the ability of the VMX-250 to enable something called a multi-target capability, which means a single laser pulse can return up to 5 individual measurement points. This is very useful for penetrating into vegetation, and here we see the color-coded multi-target capability. This allows us to get up to 5 times as many laser pulses as the 600 kilohertz. This is calibrated reflectance that runs from blue to red. This allows a single color surface to have the same reflectance whether it's taken at 10 or 200 meters, and it's a range independent surface. This is important to remember that the boat is moving up and down, and it's all controlled by the IMU. You can see here that the boat is moving on the surface of the water, and yet the top of the wall is perfectly straight. This is all post-processed using a combination of the IMU, GPS and laser measurements. So now we've finished that survey from the boat, and we now need to combine the 2 sets of data. In the background we've had a base station running within 3 kilometers. We now have post-processed this data to combine the shipborne data with the data that we took from the vehicle driving across the top of the harbour bridge. So in the next animation you will see the combination of the 2 data sets to one complete seamless data set of laser points, all accurate to within 20 millimeters true position. I think you agree this is quite an outstanding achievement from a system that's running with no interruption to whether the road or the shipborne survey. Well, thank you, ladies and gentlemen. That concludes our demonstration of the RIEGL VMX-250 mobile system. I hope you found it interesting. Thank you very much for your attention.